Hey everyone. Again, I'm Nahid Alam. Um, so I guess, as Amit introduced, I'm a staff machine learning engineer at Cisco Meraki. So Meraki it was a startup that I think about 10 or 15 years ago, I guess 10 years ago, roughly, was acquired by Cisco. I think it was 2014 when it was acquired. If you think of Cisco and kind of like the business side of it, you think of networking, but it's interesting that Meraki actually has a camera product that we sell to enterprises like other businesses like schools, hospitals, retail. And the use case is really the security and surveillance. Uh, me and my team, we sit on the intelligence side of that surveillance camera team. And I have at this point, I think this slide is probably older a little bit, so this year keeps increasing. So I have been doing hands-on machine learning in different ways. I think almost since 2016. So I don't know how many years that is. So a lot of my initial work was sort of like traditional NLP, like tokenizer, chunking, stuff like that. And then I was kind of interested in I felt that with only text and language, your understanding of this world is kind of limited. So that's why I got interested in more vision product. So that's how I eventually got into my current team. I have a background in computer science, uh, BS and MS. And actually in 2014, the reason I remember why Meraki was acquired was in 2014. Actually, I did my own startup. It didn't work. We tried certain things for like about 2 years. It didn't work. And kind of lesson learned from that point. So I mean, I think this is one of the reason I'm at in the Cohere community is although traditionally my job description is engineer, but I'm more interested in like applied research type of role. And I'm kind of doing that in my day job right now also. I have a preprint on actually vision transformer. I have a couple of patents that are, one of them is with USPTO now. It's not approved yet, so we know what happens there. And there are few works going on right now underneath. I guess this is one of the interesting thing during my journey, like when my startup basically failed around like 2015-ish. So I was not sure what to do with my life. So I worked with a venture firm for like 6 months and kind of helped them doing due diligence in like deep tech products. So coming back to Cisco, I think. So I think what happened, I guess, like before November 2022, was that there was like pre-ChatGPT era, right? And even now, really, like a lot of vision-based work are kind of like very task-specific problem solving, and it's really like it's not that need has completely gone away, but people are thinking alternatively also. So, and in some cases, these task-specific problem solving is actually needed. They do well, and when you need to solve only one problem or maybe two problems, you don't need to complicate things. So, as we have these security cameras, like our problems are sort of, if you think of the machine learning piece of it, boils down to like, okay, detection, segmentation, tracking of people is actually interesting in a retail scenario. Like, let's say you want to count how many people you have in Starbucks right now. So you want to track, you want to have like a proper track path for people entering through the door. So let's say you have a door on top of camera. So first of all, it needs to detect the change, and then uh, to be certain, you also need to know the path on the point on the space. So like lot of our work that are right now running on the product. So we have about 500,000 cameras right now deployed throughout the world, and they are the object detection models that are running there right now is actually built by me. Um, and I mean, we are kind of iterating, and there are other folks in the team working on improving that right now, because my focus has changed a little bit. So yeah, so these are sort of like the uh, classic categories, and this image is actually very nice. It's taken from Alternative. So as this camera I keep showing, but we have many different types of cameras, and there are cameras that not just direct rectilinear image, but it also takes like 360-degree view. And the way our system really works is like we record the videos when like the customer install base. Um, yeah, and so the machine learning operation happens on those videos. So like we have certain customers that has opted in for, hey, you guys can use it for machine learning purposes. So we we actually take those videos, and we have a system that detects the useful portion of the video. Because if you think of, like, let's say there's a camera on the street, most of the time nothing happens there. So in a 24-hour video, I don't know, maybe 10% or maximum 20% of that video is useful. So it's like empty road, what do we do, right? um, so we have a system that looks into that video and finds out the interesting pieces there, and from there we um, right now all these segmentation and like line crossing and detection, all these things are operates on images. So um, we build a model that the image data comes from these useful video, and then we train, and then right now all our models are deployed on the camera. So the models need to be kind of really sort of small and less parameter. Those are the constraint we specifically operate, um, and so that's one of the things that's on the training side. I think like if you look at how the companies that are like web-based companies, how they deploy and monitor the model performance is a little bit pretty different if you come to the edge deployment. I think on edge specifically right now, at least I don't know there is any tool that monitors the runtime performance of model on edge. So I mean, this might be an opportunity for if any of you entrepreneurs out there like build something that can do that. Um, so that is one of our challenge. If you compare like companies that do model deployment on cloud, because there are lots of tools that monitors performance like runtime. So in our case, we have to do like a lot of other pieces of action to kind of like, hey, when customer reports certain problem, how do we sort of diagnose those, and like why some problem really happened, like let's say false detection, or let's say like it's counting too many people, but in reality there are not that many people. So I feel like in industry, uh, I think this is where the difference between research and um, industry is. You have to think a lot about the maintenance aspect of your model. Like I love building model, I love like doing research, but like maybe sometimes I get bored of that maintenance stuff. But so when you're building product with a team, you try to get people who find that piece interesting. That hey, some problem happened, so there's a bug. So like there are people who genuinely find those things very interesting, right? So thinking about that holistically. Um, so I guess like I'll not repeat this slide, but in general, like uh, because we record video, so if you think of like uh, the typical operations that happens, trying to understand the video, as you saw before, is kind of like very task specific. Like we are doing object detection or segmentation or like whatever, right? But I guess like since November 2022, like it's almost like 2 years right now, things are kind of like shifting. Like we had almost like a seismic shift on the language space, and um, folks in the vision community is kind of like trying to see how we can sort of leverage these like generalized view of things, right? And yeah, I think I cannot see any question or anything, so feel free to like interrupt me anytime. Um, yeah, is there a question?
No, I'll let you know if any questions come up.
Sure, sure. Yeah, so I guess like you might have seen this photo somewhere in Hugging Face, I think. But uh, this concept of vision language model is really that you use one foundational model to solve multiple problems at once. So instead of one model for object detection, one model for object segmentation, one model for question answering, one model for tracking, right? You you build a generalized model that can solve like maybe at least 3 or 4 problems together, right? It doesn't have to be like over generalized like ChatGPT, like promises everything under the sun, but in in an enterprise scenario, in a company like Meraki or in a company like I don't know another company, like they might want to solve 3 or 4 problems together, right? So even in those cases, these generalized foundation models are helpful. They promise they will solve everything, but they will not solve everything. So you um, try to solve, maybe customize it, tune it in a way so that the generalized models can solve maybe 3 or 4 problems really well. So, for example, one thing I have not shown here is OCR. I think OCR is another problem that is um, pretty common in security surveillance space, and also a lot of other like non-security space also. Um, so, and it's not really our use case, but I know that there are folks on sort of on the documentation space. They are using detection and OCR kind of together. And with the current state of vision language model, with some sort of tuning, they are actually doing pretty well. Like OCR before the foundational model was, I think, really challenging. And a lot of these problems are kind of like improved. The quality of those responses in OCR has improved a lot um, after the foundational vision language models. That's what I hear. So I think
So,
yeah. Go
Nahid,
ahead.
I'm sorry, we did have one quick question that came in from
Sure.
Karan. Hey,
Mhm.
Karan, you want to come off mute and ask your question, or do you want me to ask Nahid? Okay, so Karan had a question. The question was detecting objects are based on computer vision. Um, so I'm guessing Karan's asking, is detecting objects based on computer vision? I can answer that, of
Mhm.
course, yes, but
Yes.
Nahid can go into more detail.
Yeah. Yes. Yes. It's based on image. So So from video, we have interesting images, like let's say portion of the video where things move, like people move or car moves. So then we have images, right? And then what we have is we have a third-party vendor who does the data annotation. We have contract with them, so they do data annotation. So they do, okay, this is your bounding box, these are the coordinates. So they have done a ton of data annotation. We have like millions of images. And then because, so right now we have to solve, like let's say we have a problem where we want to detect both color and detect the person. So we have we have used variants of yellow and kind of like customize it for like color right now also. So yeah, so these are really like CNN based architectures that we kind of run right now, and um, they're very good at sort of like what they do in like task specific things, and they scales very well. Like um, pretty much like it's essentially linear time scaling with CNN. So that's, and because we, and this slide is kind of related to that also, is so anything you do, you have this trade-off of like how good the quality is, how much resources you need, and what the cost, right? So one of the reasons a lot of these CNN based models actually work pretty well is they are very efficient, very uh, less parameter consuming uh, models that can be very easily deployed with like edge devices where you have very small compute and like small amount of memory. You cannot go like I think ideally you don't want to have like more than 10% of your DRAM to be consumed by like one single application. So there are multiple other things running. There are some video processing running, right? You cannot give like 100% of your memory to like some LLM, right? So that's why these CNN based models are like really useful. You can like make them like small enough for your use case and things like that. So one of because we put things on camera, put the models on camera around there versus like cloud, we get into this deployment trade-off. Like anytime we want to do something new, we can we do this on the camera? No. Okay, so then what can we do? Can we deploy the model like locally on this MacBook? Let's say our customer has MacBook, and our customer come to our portal and we run something on the browser. So that can be another option. We haven't tried that yet, but that's another option. And then obviously cloud is another option. But in each of the cases, you can see that since the video is recorded on camera, the path of inference like changes, right? The in different scenarios. So like if you can do something new that fits on the camera, you have the most leverage, basically. The in my work at least. So yeah, so it's so basically we kind of, as I mentioned, that you can actually have option to deploy model on browser. Like you can sort of go through this whole the way Olama does containerization. You can sort of follow that same purpose. I guess another approach is I don't know if you know about Web LLM. They have there are certain examples there. You can use that for like LLM deployment, but as far as I know, they don't have anything on VLM deployments yet. So you might have to customize a few things there. And yeah, so I guess this whole slide is kind of, I guess, probably a little bit of repetition also, that in any mobile / edge device, you try to keep it, your application does not consume more than 10% of your DRAM. And the mobile LLM paper actually showed this interesting calculation that if you are running a 7 billion parameter model, a fully charged iPhone can sustain only 2 hours with 10 token per second inference rate. So, what does that mean? Even like a 2 billion parameter model, I think there are a lot of two or a little bit lower than 2 billion model, like Moondream, I think, is coming. They're kind of targeting the small VLM market, right? But even that is kind of a hard sell, especially for age. I mean, it might be a good sell for like an iPhone like this, but I think it's a hard sell for us in our world. So ideally, um, in this Meraki camera and the kind of that same genre, the models needs to be less than 1 billion parameter model. Even that has challenges, but um, if it is not less than 1 billion, it becomes like even more challenging. So that is kind of like our challenge. And this slide I got from Maxime Lebron. So he actually sometimes last year he showed this interesting trend that how model sizes are in every year um, becoming like reducing, I guess, like I don't know, a lot really. So for example, if you think um, Falcon 180 billion, it was sometimes in August 2023. This on the y-axis you have um, the mmlu, like 5 shot mmlu is was like um, whatever, like it's close to like 70%, and then you see like in August uh, of this year, it's Llama 3.18 billion, or like you can say JMR2 9 billion. It's kind of have the same performance, but they are like how much? Like they are almost like 1/20th of size or something like that. Like do the division. So that was kind of the trend like he showed, and so I guess this is more of a detail, but you can I guess like the question is like, do we also see that kind of trend for the vision language model also? So yeah, so we have similar trend, and I'm as kind of like when I made this slide, I guess 3 months ago, there are probably more now. Um, is you can see like Florence 2 is basically both the models are like they're pretty small. I think there are some Lava variant right now that is I think zero point 0.5 billion parameter model. I have not tested that yet. So yeah, so that's where kind of like we stand right now in terms of like age deployment. And another thing is like I think Hugging Face recently built small LM, and they also built a small LM too, which I don't have the data in this slide. Is they have these so these are this one small LM is language only. There's no vision part here, but I guess like probably you can take um, one of the small LM as your language model, and then some sort of like vision encoder, and kind of build your own small VLM. So that can be another path. Although like it's, I feel like one of the challenge right now is unless you do something like fundamental innovation, is like you can make models small. It's a question of like how good that quality is, and does it serve your purpose. Like maybe it's not good at OCR, but let's say you don't need OCR. You need like description, one line description. So like, is it good for your purpose? So I think that's right now that's kind of a challenge. So my day job, like if you ask me about my day job, is kind of uh, involved around sort of like building small vision language model. Um, yeah, and yeah, that's what I kind of do. And right now we are also looking into um, sort of like where what are the types of hardware we can kind of put these models on, and like what sort of the performance looks like. So that's on my day job side. I'll take a pause here, and like if there is any question,
Hey,
I can.
I'm curious, Nahid. So in general, What type of embedded devices? I know, of course, cameras, but what type of embedded devices are you guys looking or experimenting with the small language models? Are you
Yeah,
getting
these are ARM-based devices, like
ARM-based
yeah,
devices?
ARM architecture. Yes, yeah.
Ah,
Um,
okay,
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 so yeah, those are like, so I guess like there's this, let's say, completely like, if you, so basically you, let's say you have a PyTorch model and you want to deploy in certain like devices, so you convert that model to ONNX format. There's a format called ONNX. So it's like open neural network, some format. And that's like a sort of standard kind of thing. And from there on, depending on which device you are deploying, um, generally those device vendors will have their own SDKs, um,
okay,
that will help you to convert in that format from Onyx. And I think those vendors typically has, um, like from because PyTorch is pretty standard, right? So from PyTorch to directly that format. So then that is there. I think if so, that's like in our case. I think if you're doing like iPhone deployment, I think you have to convert into core ML format. I don't know if you have to do Onyx before converting to core ML. That I'm not sure. But yeah, that's yeah. Yeah, and then when I say ARM based, like it can be anything. Like let's say Qualcomm has its processors that are ARM based architecture, but then it's the architecture is customized to their need. Like so, um, so if, uh, saying that ARM based is actually very wide because it's different from Intel, right? Intel is like one company; their whole thing is one set.
oh,
But ARM is like, because ARM is like open standard. So let's say Qualcomm can take the baseline ARM architecture and make changes there, right? Or like Broadcom can take that and do their own customization. So with ARM-based architecture, it's more wild west. So it would have to be more like vendor specific things. So I think
okay.
that's why this Onyx format actually also helps. I think some of the vendor also supports probably directly running on Onyx, but yeah.
Okay. So I'm going to sneak in one more question, Nahid. So, in your day-to-day work, what's probably the most interesting aspect of, your day-to-day job, and what's probably the most challenging, that you run across on a daily basis? I'm pretty sure that's changed over the last few
Mhm.
months, or it's evolved. But what's most interesting, and what's probably most challenging on a daily basis?
Mhm. Yeah, I think the challenging part I would say is, it's kind of related to the type of job. I guess my challenge might not be same for others. Is I think in general we one of the things that gives us pain is like uh, once the model is deployed, we kind of there's no way to sort of monitor the model performance runtime. Uh, so I think that I would say one of the big challenge. So I think, like in traditional like web applications, like you have this ways of like A/B testing and things like that. I think that part is kind of like missing. So one is like monitor performance runtime. Another is like, let's say right now we have a model running and I make another model, and we have like, how do I know that this current model is better than the model that is currently running?
Hmm.
So typically in you would do some sort of like web test, A/B testing kind of thing. Right now we do not have any kind of like that. Like we have framed our own way of like, okay, we have some golden test data set, let's say, but then as you see, like these are, um, you can, I think this, first of all, this can be more exhaustive. That's like on us, like if we want to make it more exhaustive, that test data set. But like, again, these are kind of like statistical scenarios, right? Like there are like customers, you don't know, like someone's backyard uh, put something, and then like some flower pot or like some cat moving, and it's like, let's say it's detecting as human, right? So I think those random scenarios, it's harder to understand that those scenarios will happen beforehand. So as we evolve, we keep improving our test data set, but then I think it's still a challenge. So yeah, so that's the challenging part. I think the interesting part is right now so I guess like a lot of like some of these VLM piece, I think is there are a lot of challenge there to actual deployment and kind of to make it actual reality. There are a lot of challenge. I feel like I have like 1 year worth of work on that side. So that is interesting because like if we can deploy like a actual workable VLM that is solving like let's say one simple problem, I think that's a win. So yeah, that's interesting. I think.
Okay.
Yeah, so I guess like I Uh, I think we have like 15 minutes, so I want to do like a very quick overview of Maya actually. So uh, this is funny. I don't know if we have that story here. Yeah. So I think this was sometimes in May 2029, May 29, 2024. So I think in Cohere there is this channel called like No Bad Ideas, and like you can put some ideas and kind of like get feedback. So I had this strange thing that okay, we are hearing a lot about Aya, which is like multilingual language model. But it does not understand the multimodality, right? Like it doesn't understand image, or it doesn't understand video, or like it doesn't understand audio, sound, stuff like that. So you know, I had this thought of like, okay, what if we build a, a multimodal, multilingual model. There are too many M's, so I kind of jumble up sometimes. So um, we can use AI as a language model, but make a multimodal model out of it. So yeah, so that's I think that's I don't know if you kind of understand that. So let's say you give an image as an input and say, hey, describe this image to me, and it outputs you on, let's say, on English, right? So there are models like Lava kind of does that, and there are many other models. And but like, what if you say, describe this image to me in Chinese, in Spanish, or like some other language? Um, so that's what Maya is about. And yeah, so I guess like what one of the like what we kind of thought was, okay, so when we started, like there were like there most, of course, like most vision language models are English focused, and there are probably some that are like one or two languages. And one of the reasons really was that we actually lack quality open source data that is multilingual and multimodal, right? So that lack of data set also sort of leads to this problem, why we don't see those kind of models. And I think that's, I guess, like I won't say that data set problem has changed so much, but there are folks who are kind of doing this type of multilingual, multimodal model, for example, Quen, and I think there's another model called, I don't know if I'm saying it right, Ping or something, recently came out. So yeah, so with Maya, basically we want to create an open data set that is multilingual and multimodal. We'll open source that data set soon, not yet. And using that, we want to build this model that understands text and images in multiple languages. So right now it will understand like 8 languages well. So So basically, what we did was we used the Lava architecture as our baseline, and um, we replaced the language in Lava. The language model is Vicuna. We replaced that with Aya, and we replaced the vision encoder that we have in Clip with Siglip, and then obviously we did a ton of work on the data, and Karthik and Surya and um, I think Anthony, Shaik, Snegha, Isha, Drishti also, and I don't know if I'm missing any names. So that was the dataset team that um, worked on creating 8 language pre-training dataset for on this multimodal space. That I'll not go into the detail of this, but one of the things we did was we used uh, so we took the pre-training English pre-training dataset from Lava, and we did translation of that data with using IR35B model that support, and then we the dataset team actually worked on very rigorous step in terms of like improving the quality of translation. So they looked into uh, I think 6 different prompt and see which prompt actually gives a good translation on like a sample small data set. We manually reviewed human resources the quality of the translation, and based on that we decided that okay, which prompt is giving us, we are calling it preamble here, but which prompt is giving us a good quality of translation. So that and then I think eventually we um, helped I think the IR's command R system to um, verify again like the quality of the translation. So we did a lot of work on improving the quality of translation from English to those 8 languages. And we also, another interesting thing that happened was we found out we found a there's a project called Lava Guard, so that helps you kind of detect like let's say some unsafe or like toxic content on image, like let's say I don't know some child abuse, like animal brutality, things like that on images that we found out that on Lava dataset it is there and nobody actually talked about it before. So we found that out, and once we found that out, we used LavaGuard for understanding the image toxicity, and then we used ToxicBird to find the toxicity on the text dataset, and we removed those data to create like a cleaner version of that dataset. So you will, we once we release the data, you'll see that both um, the original translation and the toxicity-free translation that will make all of them available. And yeah, we kind of like use that to filter, and then all sorts of like data verification and things like that went, and then yeah, we this is sort of the Lava architecture that we used. Basically, the language model in our case is Aya 8 billion model. Yeah, and that's how we. This is like sort of training results, and that's how we build the model. This is one example um, output. I think there are like more outputs. I don't have all the outputs right now, but yeah. So that's I can try to find out some sample output. Okay. 1 second. I'll show you one sample, some interesting output. Uh, I have it. Just let me open it. Um, yes, share it. Yes. Do you see the PDF I'm sharing, like with an image?
It's coming up now. Um, Not quite yet. You may have to, now you may have to share your entire screen.
Okay, let me share. I don't let me. Shit. I don't know if it doesn't show me entire screen thing also. So it just shows me share this window, share this window. Okay, I can. Okay, you should be able to see it now. Do you see it?
Yeah, we can see it now.
Yeah. So this is like a, I don't know. This is like there are too many pages here, but so for example, like one example is this sort of like this food thing. Like so we ask like, okay, describe this in detail, and then um, you can see like what are the response from Maya, and then the way we evaluated is we looked into the response of GPT-4, and then using the LLM as judge method, we evaluate that whether how good Maya's responses are. So for example, this is one example, like what brand is featured in this in this image, and then okay, Maya replies something, GPT-4 replies something. So this is one example, and I think so. There's can show. Um, do you see this multilingual output?
No, we still see the PDF, so you might have to share that particular window as well.
Okay. Wait, yeah, I can do that. Yep. So for that, the food image you saw, that noodles and stuff like that. So like we say, okay, describe this photo in detail, and then it will give you English response. But if I say describe this photo in detail in Spanish, then it will give you this Spanish response. Like you can say you can specify the language in Spanish, in French, in Chinese, in Japanese. So basically all the 8 languages that we pre-trained on, and we actually instruction tuned the model on 10 languages because our dataset had that. So for example, Bengali and Urdu, um, we did not pre-train the model. We only instruction tuned. So kind of you can see the output there, and like I understand Bengali, so I know this is the correct output. It's not as detailed as like let's say GPT-4, but also they are like the GPT-4 is like a trillion parameter model. Maya is like 8 billion parameter model, so they're in a completely different scale, and scale of training, scale of the architecture, everything is like very different. So yeah, so
Hey,
that's what we did. Yeah.
I had a question, Nahid. So I know, during the evaluation of Aya Expanse, for example, for German, of course, it was noticed that there are quite a few differences depending on the various dialects of German, say from high German to low German, or high Dutch to low Dutch. So I'm curious, for Aya, did you guys as well, when you were doing your fine tuning, did you also do a little bit of testing for regional dialects, especially say, for example, for Spanish?
Yeah, so we not I don't think we did on the model evaluation phase,
Okay.
because our evaluation is not like the way you do evaluation with like a lot of these AI expands, and like there's this language bot arena kind of thing. Like we don't have that setup.
Okay.
But like so basically this is where when Karthik, Surya, and the dataset team worked on the translation piece of the dataset, that's when they handle that dialect piece. Karthik, you want to talk about it?
Oh yeah, go ahead, Kartik.
Yeah, so thank you, Nahid. So far, it's informative. Uh, yeah, so regarding the dialect piece, the
Uh-huh.
main thing we took care of is when we were translating the image captions that are in English. So we want to make sure that whatever the image caption specifies, it has to be translated to the specific dictionary word in that language, rather than just transliterating English to the particular language. Let's say you take a color as pink.
Mhm.
It is a color we all know in English, but let's say you take French as a language. In French, do you think there is a word in the dictionary called as pink? They don't actually have it. So you're transliterating that word. But
Uh,
actually, how do you resemble pink in French dictionary? It is called as rosé. So it our captions, image captions, they pick the actual dictionary words rather than just transliterating. So that kind of dialect piece we handle, but I'm not sure about the entire sentence formation, but I'm sure the way it responds for the particular images in those specific languages, it it will be like a native spoken kind of thing.
okay.
I guess there is a rule for this. Nahid would say, is it RTB, Nahid? If I'm not wrong.
What is your question, Karthik? I didn't get the question.
Is it the RTB, like the dictionary word that I explained you earlier?
Yeah, yeah. I forgot the name. It's like I know what you're saying, but yeah, it's basically, for example, it's kind of like root based thing. Like
Yeah,
I think Arabic has that. Like let's say, like yeah, I'm not good at Arabic, but it's like let's say same root can be placed in different ways in like different to make different words with different meanings. So I think that's what Karthik is saying about when he
yeah,
says dictionary based. Yeah.
yeah.
Okay.
Even if you think of the word pink, right? In Hindi, there isn't a specific word called pink, but instead people refer in Hindi, actually the native speakers, they refer pink as a color called as gulabi. So so basically we are trying to handle the nativeness of the explanation rather than just trying to transliterate those image captions.
So I know initially, the 8 languages were addressed with Aya. What's coming down the pike, Nahid? What languages are next? Will there be another batch of 8 languages, or what's coming out in the near future?
Yeah, I think the near future is, I mean, that I guess like I would like to make that 8 languages to that 10 languages to kind of like be on par with the instruction tuning data set languages that we have. I think I guess Karthik is working on improving the quality even more, and I guess the no Hindi Karan Hindi is already there. We don't have Punjabi. I think the two missing languages on the pre-training data set is Bengali and Urdu, but we have them in the instruction tuning dataset because we are using Palo's instruction tuning dataset, so which has that. So yeah, so that would be good. I think right now, I guess probably another interesting thing is our instruction tuning dataset right now is 150K, but I think we can make it uh, how much like 665K, I think, right?
Yes,
Uh,
yes,
so I feel like that will be a good improvement. Like if you think of what will give model sort of like qualitative improvement in like leaps and bounds, I feel like that will be that. And then there are like tons of other things like doing more thorough evaluation and like um, I think I personally am interested in kind of like alignment aspect a little bit more. Um, and then like sky's the limit. Like you want to do something on video, like sure, let's talk.
Hmm.
So yeah.
Okay. So before we complete it, I know ordinarily we have a question from Mayank. So I just wanted to give you a chance, Mayank, before we finish to see if you had a question as well.
Yeah, I was thinking about the compute. So you last time mentioned that you had some limited compute and you were training on that. So is there any workaround did you find, or did you get?
No, I'm right now I'm using my personal compute. I have some grant on, like, I can use A100 on Google Cloud. So it's not my biggest worry right now. Probably not next 6 months. So yeah, I mean, I'm not worried about compute for myself at this point. I think what would be helpful is, like, if we had more compute grant. I think some of the team members on the modeling side could have done a bit more experiment. So that would have, like, I feel like a lot of things are bottlenecked on me on the training side. I think that would have helped. It looks like we have, like, a couple of other team members that got access to their school compute. So that's a possibility. I think that will be there next 6 months. Um, so yeah,
Uh, yeah,
it's
so
there,
cool.
but I won't say it's the biggest worry right now. Yeah.
Thanks.
Okay. Were there any other questions from the attendees? I know we're at our hour now. I wish we could go on for another hour, but I think we all have to get to work now. But were there any other questions from the attendees today? Okay, well, this was actually an excellent conversation, Nahid. Thank you so much for joining. And to be honest with you, listening to you and Kartik talk, we have a couple more ideas I want to address with you and Kartik later for future sessions, especially on AYA for the vision component. So this gave me an idea for 2 or 3 more sessions. So thank you.
Yeah. Thank
Okay.
you. Thank you for inviting. Yeah. Thanks.
Well, thank you, Nahid. Thanks everyone for joining.
Thanks.
Okay, have a good day. Bye.